how to build an LLVM-based OS, LLVMOS, on a Raspberry Pi. Have you ever wanted to create a minimal Linux system that runs primarily using LLVM and GNU tools? If so, you're not alone. Many developers and educators are experimenting with lightweight, custom operating systems built around LLVM. In this guide, we'll walk you through setting up a custom LLVMOS on a Raspberry Pi, using Openbox and GCC/Clang. What is LLVOS? LLVOS stands for Low-Level Virtual Machine Operating System. It's not an official OS, but rather a concept, a minimal Linux-based environment built to use LLVM/Clang as the core compiler toolchain. Run minimal X11 GUI with Openbox. Leverage GNU tools for development and experimentation. What you'll need: a Raspberry Pi, Model 3, 4, or newer recommended. A microSD card, 8 GB, or more. A computer with Raspberry Pi imager, or balenaEtcher. An internet connection. A keyboard, mouse, and monitor for the Pi. Step 1. Flash a minimal Raspberry Pi OS image. Download Raspberry Pi OS Lite, 32-bit, from the official site. Use Raspberry Pi imager, or balenaEtcher to flash the image onto the SD card. Insert the SD card into the Raspberry Pi, and boot up. This image gives you a minimal terminal-based system, perfect for building from scratch. Step 2. Log in and install basic tools once the system boots. Bash copy editor sudo apt update sudo apt upgrade y sudo apt install Zorg Openbox xterm GCC Clang LLVM make build essential y Zorg. Provides the X window system. Openbox. Lightweight window manager. Xterm. Simple terminal for GUI. GCC, Clang, LLVM. Install both GNU GCC and LLVM/Clang compilers. Step 3. Set up a minimal Openbox GUI. Create a .zinidrc file to launch Openbox. Bash copy editor echo exec Openbox session ~/.zinidrc. Now, start the GUI manually with Bash copy editor start X. You should see a bare desktop with a right-click menu from Openbox. Step 4. Compile and run LLVM/Clang applications. Try creating a test C or C++ program using Clang. C copy editor //hello.c include stdio.h int main print hello from LLVOS !n return 0. Compile it with bash copy editor clang hello.co hello./hello. Want to test LLVM intermediate representation IR. Bash copy editor clang s emit LLVM hello.co hello.lli hello.ll emit LLVM creates IR. Li is the LLVM interpreter, executing the .ll file directly. What you've created: you now have a lightweight development environment where both GCC and LLVM/Clang are available. GUI is minimal, but functional. You can write, compile, and test C/C++ or LLVM IR code. It's your own LLVMOS, lean, fast, and customizable. Why use LLVM on Raspberry Pi? Great for learning compiler internals. Ideal for embedded systems testing. Lightweight enough for the Pi. Flexible for systems programming, security research, and education. Final tips: you can install a file manager like PCMantham, or a web browser like Midori, if needed. Use Tmux or Screen for multitasking in the terminal. Want to go further? Try compiling your own Linux kernel with Clang. LLVOS isn't an official OS, it's a concept you build yourself. But with LLVM, Openbox, and GUI, you can learn and explore systems programming from the ground up.